from your local news leader, Karina Rubio, Matthew White, and Central Illinois' most accurate forecast with meteorologist Adam Sharinsky. You're watching The Morning Show at 9 on WCIA 3.
As always, we thank you for staying with us on The Morning Show. You at home have maybe wanted to build a quantum computer. Well, to most of us, that sounds pretty complicated, but we also have someone here to help explain it more.
That's right. Joining us on The Morning Show is wise guy Paul Kwiat, and we're also joined by a second guest, U of I physicist Professor Angela Kou. Thanks so much, both of you, for being here this morning. So go ahead and just jump in. Tell us what you guys are working on right now.
Yeah, so I've talked before about quantum information a little bit, and I had one of my other colleagues, Brian DeMarco, who works on one sort of platform for making quantum computers using atoms and such. And my colleague Angela here works on one of the other most popular platforms. I guess I do light, but she works on another thing using cold metals, basically.
Yeah, so in your kitchen, you probably have aluminum foil. And then so what we do is try to build a quantum computer using aluminum, so very, very pure aluminum foil, cooled down to very cold temperatures.
And hopefully people still have some left over from Thanksgiving, all those leftovers. But Angela, walk us through. There might be people at home who have that same idea of starting to build that computer. What's your approach? And then also, how does it encode information?
Yeah, so the idea is that our computers are based on bits. You can think of this as a switch. It can be an on or off, right? Okay. Quantum computers are based on a slightly different building block. It's known as a qubit. You can think of this more like a dimmer switch. It can be kind of on, kind of off, and this allows us to have more computing power compared with a classical computer for certain problems. And then so the idea is that we're trying to build these kind of dimmer switches so that they can be used in the future to solve materials problems or computing problems that anyone might have.
And can you guys expand a little bit more on what they will be used for and exactly how long they can run?
Okay, so right now we're still in our research stages, so we're trying to figure out the best way of building these building blocks that I mentioned for a quantum computer. And so we're trying to make them run as long as possible, but right now they're nowhere near classical computers, so it's still a research problem. But if we get them to the point where they can be useful, then we can try to use them to look for new materials, for new ways of optimizing traffic, or for new ways of making our computers faster.
Okay, and I think there's a talk that you're going to be having on Saturday coming up to maybe expand further for our communities who are interested. Can you walk us through what people can expect if they plan to go to your talk?
Yeah, so we're having a Saturday Physics for Everyone talk where we try to make the concepts that we're talking about more accessible. And then so what I'm going to be talking about is the difference between the computers that we use now and the computers that we want to build, and also our approaches for building these computers and why it's so difficult and why it's such a big research problem for trying to build a quantum computer.
All right, and for those who maybe want to head to that on Saturday, we had those details on your screen. What building is this on again on the U of I campus?
It's in Loomis Laboratory of Physics, which is on the corner of Green and Goodwin. And there's free parking both to the west side and the east side that you can come to. It is at 10:15, completely free. And we'd love to see lots of people out there and find out all about how to, maybe not how to make your own quantum computer, but what a quantum computer would look like, and even connections to other things we've talked about on the show before. So.
Yeah, maybe going to that talk first on Saturday would be a good step one. All right, Angela and Paul, thanks so much for being here this morning.
Thanks, everyone. See you guys later.
All right, make sure you stick with us. Adam has your forecast up next. We'll be right back.